This video is about giving you a quick test of a range of topics that will come up in the GRE Quant. All of these topics could also come up in the GMAT Quant. We've got a mix of wordy questions, algebraic questions, geometry questions, and others, with 5 in total. As always, pause the video as you're going along and try the questions out yourself, because some of them are deceptively hard. But as I say, there's a range of different difficulties in this set. I'm also going to be showcasing a nifty thing where I can annotate the screen. So let's see how that works. Let's start off with example 1. By the way, these questions are from Target Test Prep and the link is in the description. Okay, first question. The table shows 2 certain food items, peanut butter and soup. I don't necessarily always read all the captions, so I'm going to skip some bits here. This is what I would realistically do. Peanut butter soup here, tablespoons, 1 cup, servings, calories, etc. Then it says Erica loves peanut butter in her soup. At lunch, she adds 1 tablespoon of peanut butter. Interesting, they say 1 tablespoon of peanut butter when the chart says 2 tablespoons. I'm guessing that's going to be a trick. To the entire can of soup as she is warming it. Assuming that she will eat the entire can of soup, by what percent has she increased the caloric value of her lunch soup? So she is adding 1 tablespoon of peanut butter, and they're talking about calories. Now, we know 2 tablespoons equals 190 calories. TBSP, by the way, is tablespoon. So therefore, 1 tablespoon would be half of that in terms of calories. I can do that in my head, but obviously you can use a calculator if you want. That would be 95. So we've got 95 calories in a tablespoon, and she's adding that to 1 can of soup. Now, we don't know how many calories. We know 1 cup is 250, but it says servings per container is 2, meaning I'm reading that as being the entire can or container has 2 servings, so it has 500 calories. That's how I'm reading it. Quite a wordy question, even more wordy perhaps than the real thing. But notice how I didn't necessarily read absolutely everything, just the core stuff that I needed to know. I don't need to know about fiber, I don't need to know about saturated fat. Okay, so she's adding 1 tablespoon, which is 95, to 1 entire can of soup, which is 2 servings, so 500. By what percent has she increased? Do you know the percent increase formula? So I've got my calculator here. So the percent change formula is the difference or change. So she's added 95 over the original. And the original here was 500, the can of soup. So 95 divided by the original, which is 500. And let's move this so you can see that, would give us 0.19, which is a 19% increase. Obviously, you times that by 100 to see the percentage, but we can just say that's a 19% increase. So let's check our answer by going to the original website, and that is 19. And there we go, C solution, that was correct. And it just talks about the percent change formula. The real challenge, I would say, was interpreting the diagram and knowing how many words to read and how many words not to read, like how much of the table was important and how much was not important. So as I say, a couple of bits of the table weren't that important, but other parts like the servings and the serving size and the calories were important. Okay, let's do the next question here. A particular triangle has a height that is twice its base. If the area of a triangle is 100, what is the length of the base? Quick thing here. Some of you may want to pick numbers, and I would say that you can pick numbers if you use the numbers on the left, but this isn't an example where I would be inclined to pick numbers. Why? Because we have an equation involved. I always talk about if there's an equation, I don't tend to pick numbers, and they've told us that the area of the triangle is, which means equals, 100. And that's an equation, so I try to solve these properly using algebra rather than picking numbers. I find that's quicker. Let's find out. Let's draw this triangle. the height is twice its base. If we're going to do these things properly, we're going to use x. So x would be the base, 2x would be the height, because the height is twice the base. Don't bother with two different letters like h and b or something. Just use x and 2x. Now it says the area of the triangle equals 100. How do we find the area of this triangle? Well, we would do 2x multiplied by x. That's the base, or the height times the base, and then divide by 2. Base times height, divide by 2. And that would give us 2x squared over 2, which is just x squared, because the 2's cancel out. So x squared, and don't forget this area equals 100. So x squared equals 100, meaning of course that x equals 10. Or minus 10, but in geometry you can't have negative lengths. So x is 10. Now don't rush and pick 10. Were they asking for the base or the height? They were asking for the base, so the answer is 10. But if they were asking for the height, it would be 20. So be careful, don't just rush just because you've worked out x to pick the answer. Check that that's what they're asking for. So to summarize here, if we'd have picked numbers using a back solving approach, where by the way you start with b and then do d and then extrapolate, it would have taken a bit longer. And how did I know to use algebra instead, even though I could have picked numbers? Because there was an equation involved up here. The area of the triangle is 100, meaning it equals 100. Let's check our answer back on the original website. And that was correct. And they've done much the same thing. Okay, let's do the next question. It's fun for me because I'm annotating the actual website. It's much easier than using OneNote. Anyway, this one looks interesting. In a fishing box with red, blue, and green worms, I haven't done these questions before, by the way. The ratio of red worms to blue worms is 5 to 6, okay? Ratio of red to green. Okay, this is going to be overlapping ratios. If you haven't seen my video on overlapping ratios, this might seem like a difficult question. If you have seen my video on overlapping ratios, this will probably seem like an easier question. What do we do with overlapping ratios? We do a table with all the objects in one row at the top. R, B, G, Ruth Bader Ginsburg. Anyway, we've got 5 to 6 for red to blue. So we put that there, 5 to 6 for red to blue. Then the ratio of red to green is 4 to 3. So underneath, we do 4 to 3 for the ratio of red to green. Now, in my overlapping ratios video, I talked about how you look at the column where we have an overlap, which is the 5 and the 4. And then we just say, what number can we make 5 and 4 to make them both the same number? In other words, is there a lowest common multiple of 5 and 4 that we can think of? In this case, it would be 20. 5 goes into 20 and 4 goes into 20. How do we make 5 and 4 20? Well, to make 5 20, we multiply by 4. And to make the 4 20, we multiply by 5. When you multiply the 5 by 4, for example, you have to remember to also multiply everything in that row by 4. So we also multiply the 6 by 4. When we multiply the 4 by 5 to make it 20, we've got to remember to multiply everything in that row by 5. So the 3 also gets multiplied by 5. And if you haven't seen this before, you're wondering what's the point of all of this. Well, look how red becomes 20. Because 4 times 5 is 20. The B was 6 times 4, which is 24. And the 3 times 5 is 15. And now we have one ratio that unifies all three values. Without having that common number, the 20 in this column, we couldn't have unified the ratios. We just had two separate ratios. But by making that column having a lowest common multiple, we now have a ratio that links all three values together. Really important here. Notice how I did all of this without even really knowing what the question was, just because it's useful to do. It's always going to be useful to do. You don't always have to read all the way to the end of a question before you start getting to work. Now let's answer the question. How many blue worms could be in the box? Well, we have to use this final ratio. So blue is 24, not the original, which is, if you look, blue was, I think, 6 in the original. So many of you would pick 6. But that's actually wrong, because using our unified ratio, we know blue has to be 24 or a multiple of 24. Red has to be 20 or a multiple of 20. The number of green worms has to be 15 or a multiple of 15. So in this case, they're asking about blue. So the number of blue worms has to be 24 or a multiple of 24. And that will be 48 and 72. Obviously, you can check those multiples in the calculator by doing 24 times 2, 24 times 3. I just did that in my head. So what I'm going to do at this point is finish off the quiz, 2 more questions only, and then we'll check all the answers and solutions at the end. Either way, this is the correct method. And if you want to see more examples, check out my video on overlapping ratios. Anyway, example 4. Again, feel free to pause and try yourself. If 24 to the power of 4 multiplied by 16 to the power of x plus 3 equals 18 squared, then x is equal to which of the following? Now, I would honestly say this is possibly the most important example in this set because it's an incredibly common question type. So really try your best on your own and then check if your answer matches up with mine. Very first thing to do, and most importantly, we need to prime factorize. Whenever you see numbers with exponents, those little numbers at the top, the powers, prime factorizing is almost always a good idea. It's so hard to compare 24 with 18 or 16 with 18, but if we prime factorize, it should be much easier. So even though you might nod your head and agree with me doing it, would you have thought to prime factorize? Let's start with 24. So breaking down 24, 24 is 8 times 3, and 8 is 2 cubed. So we actually have 2 cubed times 3, that's 24, to the power of 4. Notice I'm not calling it 24 anymore, I'm calling it 2 cubed times 3. Let's do the same thing to 16. 16, hopefully you know off by heart, is 2 to the power of 4, but if you didn't, it was 8 times 2, and 8 is 2 cubed, as we saw earlier, so in total there are 4 2's. There's 1 there, 3 more there, so either way it's 2 to the power of 4. So I'm not going to call it 16 anymore, I'm going to call it 2 to the 4 to the power of x plus 3. Finally, let's do that to 18. Let's give ourselves some more space here. So 18 is, break that down, 9 times 2, and 9 is 3 squared. So if we're going to write this out properly, we'll now write it out only using prime factored forms. So 24 is 2 cubed times 3 all to the power of 4 times 16, which is 2 to the 4 to the power of x plus 3, equals 18 squared. And 18, as we saw, is 3 squared times 2, all to the power of 2. I haven't really changed anything. I've just changed the base number. I've changed 24 into 2 cubed times 3. I've changed 16 into 2 to the power of 4. And I've changed 18 into 3 squared times 2. Otherwise, I haven't really changed anything. Okay, let's make some progress here. I'm going to erase to give us some space. So that was just the trees that I'm erasing, which told us how to prime factorize. And now the next step is we're going to multiply out to see what the exponents become. Okay, you should know that when you have brackets, you multiply the little powers. And if I was being professional, instead of writing a 3, I'd have done 3 to the power of 1. Instead of writing a 2 here for the 18, I'd have done 2 to the power of 1. And as I said, when there are brackets, we multiply. So the 3 gets multiplied by the 4, and the power of 1 gets multiplied by 4. So we have the 24 becomes 2 to the power of 12 and 3 to the power of 4. Just to quickly explain what I did there again, do you remember how the 24 equals 2 cubed times 3? First, I added a little 1 as a power of 3 because instead of writing the number on its own, just a 3, it's better to write it as 3 to the power of 1. Second of all, do you remember it was 24 to the power of 4? So we had a bracket around the 24 and it was to the power of 4. And I'm saying whenever there's a bracket and a power, you multiply the little numbers. So the 3 from the cubed got multiplied by 4 to become 12. And the 1 from the power of 3 got multiplied by 4 to become 3 to the 4. Let's do the same thing for the next number here. What would we do? We'd multiply the little numbers. So we've got 4 here as the power multiplied by the x plus 3 on the outside. 4 times x plus 3 is 4x plus 12. So that is the solution for the next one when you're multiplying. Do you want to try multiplying out the final bracket, the 18? Well, multiplying the powers, the 2 times 2 becomes 3 to the 4, and the 1 times 2 becomes 2 to the 2. Now obviously, I'm explaining these steps in detail. With more practice, you get faster and faster at these steps, but they are very, very important. So feel free to rewatch this section or check out my video on prime factorization and exponents, because I've done, I think, at least 2-3 videos on this topic. Anyway, how do we finish off? Well, first you can notice that we have a 3 to the 4 on the left-hand side of the equation and a 3 to the 4 on the right-hand side, so they're going to cancel out. Second, let me test you. When we have 2 to the 12 here on the left, multiplied by 2 to the power of 4x plus 12, what do we do to the exponents? What do we do to that 12 on the left and the 4x plus 12 on the right? If you said add them, you're right. When you multiply numbers with the same base, you add the exponents. So 12 plus 12 is 24, giving us 4x plus 24, equals still 2 to the 2. Okay, we're almost at the final step. Notice how we have this equation with 2 to the power of 4x plus 24 and 2 to the power of 2. We can simply cancel out the base numbers. We cancel out the 2's and we just compare the powers. So we now know that 4x plus 24 must equal 2. A lot of students hesitate at that step for some reason, but that's exactly what we do. We've essentially cancelled out the base numbers and just are left with an equation involving the powers. 4x plus 24 equals 2. Finally, solving that, take away 24 from both sides and you get negative 22 and divide by 4. So x equals negative 22 over 4, which in my head would be 5.5, negative 5.5, answer D. So I know my working out wasn't the most beautiful, but that's how you do it. If you see numbers with exponents, you prime factorized. So we prime factorized the 24, the 16, and the 18. Second thing to know, equally important, that we write a power of 1 if we just have a base number like 3 or 2. Don't just leave it as 3 or 2, write 3 to the power of 1 and 2 to the power of 1. Thirdly, we multiply the little numbers, the exponents, if there are brackets. And fourthly, you can cancel stuff out if they appear on both sides of an equation. And we add the powers when we're multiplying numbers with the same base. Finally, you can cancel out the base numbers if they are both the same on both sides of the equation. A lot of steps, so feel free to rewatch or try this question again tomorrow and see if you remember how to do it. Again, the link is in the description. And also do check out my videos on exponents. Either way, let's finish off this test with question number 5. So we have an equation here, 2 equations. Let's see what we can do. Quite important here, my very first instinct would be to get rid of the fraction in that second equation. I just see the fraction, I just immediately want to get rid of it. How do we get rid of it? By multiplying both sides by 2. So z equals 2x plus 2y. I just had to do it. And once I've done that, we can notice something quite startling. Look, we know that z equals 2x plus 2y, and the other equation says 2x plus 2y equals minus 4. Therefore, it must be that z equals minus 4. Just to recap what we did there. I saw this equation on the right, and I don't know about you, but it just jumps out that we want to get rid of the fraction. And to get rid of that divide by 2, we multiply both sides by 2. So it becomes z, just 1z, equals 2x plus 2y. Then I noticed, and it's always good to be paying attention to this kind of thing because there's always shortcuts involved, that the 2x plus 2y is the same 2x plus 2y that's on the other equation. So if z equals 2x plus 2y and 2x plus 2y equals negative 4, then z must equal negative 4. And if z is negative 4, quantity A is negative 4, and quantity B is positive 16, because negative 4 squared is positive 16, so quantity B is bigger. So we can check our answers, but I really hope you enjoyed this little quiz. So just checking our answers here, we had for this question, it was negative 5.5, and they would do it the same way. Look, they prime factorized the 24, 16, 18, multiplied and solved it. And for this question, I think we got quantity B was bigger as 16, and they did the same thing. I would imagine multiply both sides by 2, compare and contrast. And I think we also did example 3, but I've noticed it doesn't allow you to check that one. So we can't check, but it was 24, 48 and 72. Either way, I really hope you enjoyed this little quiz. Please do let me know in the comments if you did. And do feel free to check out any of my other videos that cover topics that you saw today. Have a great day.